Mars and Its Canals by Percival Lowell. Chapter 10. The Blue-Green Areas. Descending now equatorwards from the polar regions, and there in part paleocrystic, in part periodic coating of ice, we come out upon the general uncovered expanse of the planet, which in winter comprises relatively less surface than on Earth, but in summer relatively more. 40 degrees and 86 degrees may be taken as the mean hymal and estival limits, respectively, of the snow on Mars, 45 and 75 as those of the Earth. Whatever ground is thus spared of superficial covering on Mars lies fully exposed to view, thanks to the absence of obscuring cloud, and it is at once evident that the terrain is diversified, patches of blue-green alternating with stretches of reddish ochre. Of the two opaline tints, the reddish ochre predominates, fully 5/8 of the disk being occupied by it. It was early evident in the study of the surface of Mars that its ochreish disk was not spotless. Huygens, in 1659, saw the Syrtis Major. From this first fruit of areography dates, indeed, the initial recognition of the planet's rotation, for on noting that the marking changed its place, he inferred a turning of the planet upon itself in about 24 hours. 13 years later, he observed and drew it again, and this time in company with the polar cap. Again, after 11 more years, he depicted it for the third time, and now so changed because of the different tilt of the planet toward the Earth that it may be doubted whether Huygens himself recognized it for the same. But that he drew it correctly, a globe of Mars will at once show. From such small beginning did areography progress to the perception of permanent patches of a somber hue distributed more or less irregularly over the disk. Impressing the observer simply as dark at first, they later came to be recognized as possessing color, a blue-green, which contrasted beautifully with the reddish ochre of the rest of the surface. Cassini, Maraldi, Bianchini, Herschel, Schroeder all saw markings which they reproduced. Finally, with Beer and Medler came the first attempt at a complete geography. In and out through the ochre was traced the blue, commonly in long Mediterraneans of shade, but here and there in isolated Caspians of color. With our modern telescopic means, the dark patches are easily visible, the very smallest glass sufficing to disclose them. When thus shown, they much resemble in contour the dark patches on the face of the moon as seen with the naked eye. Now these patches were early taken for lunar seas and received names in keeping with the conception, as the Sea of Serenity, the Sea of Vapors, and so forth. Following the recognition of a like appearance, like appellatives were given to the Martian markings, and the Mare Serenum, or Sea of the Sirens, the Mare Cimmerium, and others sufficiently proclaim what was thought of them at the time they were thus baptized. Indeed, if a general similarity be any warrant for a generic name, they were not at the time ill-termed. For common to all three bodies, the Earth, the Moon, and the planet Mars, is the figuration of their surfaces into light areas and dark. In the Martian disk, as in the lunar one, we seem to be looking at a cartographic presentation of some strange geography suspended in the sky, the first generic difference between the two being that the chart is done in chiaroscuro for the Moon, in color for Mars. On mundane maps, we know the dusky washes for oceans, so on the Moon it was only natural to consider their counterparts as Maria, and on Mars as seas. Nor did the blue-green hue of the Martian ones detract from the resemblance. But in something other than color, these markings are alike. In fact, color could hardly be excused for considering the lunar Maria what their name implies, for distinctive tint is lacking in them, even to the naked eye. It was in form that the likeness lay. Their figures were such as our own oceans show, and allowing for a sisterly contrast amid a sisterly resemblance, the lunar Maria or the Martian seas might well have been a similar origin to those with which our schoolboy study of atlases had made us familiar. Thus did similarity in look suggest similarity in origin, and intuitive recognition clothe its objects with the same specific name. Considerable assumption, however, underlay the pleasing simplicity of the correlation on other grounds, consequent not so much upon any lack of astronomic knowledge, as, curiously, upon a dearth of knowledge of ourselves. We know how other bodies look to us, but we ignore how we look to them. It is not so easy to see ourselves as others see us, for a far view may differ from a near one, and a matter of inclination greatly alter the result. Owing both to distance and to tilt, we lack that practical acquaintance with the aspect of our own oceans viewed from above, necessary to definite predication of their appearance across interplanetary space. Our usual idea is that seas show dark, but it is also quite evident that under some circumstances they appear the contrary. It all depends upon the position of the observer and upon the position of the sun. Their usual ultramarine may become even as molten brass from indirect reflection, while on direct mirroring they give back the sun with such scarce perceptible purloining of splendor as to present a dazzling sheen not to be gazed upon without regret. Canopied by a welkin, they assume its leaden hue, while at the same time their shores, less impressionable to borrowed lighting, show several tints darker than themselves. Surfaces so sensitive to illumination hardly admit of more accusable tint than a chameleon. Nevertheless, we are probably justified in our conviction that, perpendicularly visaged, they would on the whole outdo in somberness land round about them, and so be evident as dusky patches against brighter ground. One phenomenon we might with some confidence look to see exhibited by them were the oceans, and that is the reflected image of the sun visible as a burnished glare at a calculable point. Specular reflection of the sort was early suggested in the case of Mars, and physical ephemerides for the planet registered for many years the precise spot where the star-like image should be sought. But it was never seen. Yet not till the marine character of the Martian seas had been otherwise disproved was the futile quest for it abandoned. Indeed, it was a tacit recognition that our knowledge had advanced when this column in the ephemeris was allowed to lapse. On this general marine ascription, doubt was first cast in the case of the moon. So soon as the telescope came to be pointed at our satellite, it was evident that the darker washes were not water surfaces at all, but very palpably plains. Long, low ridges of elevation stood out upon them like prairie swells, which grew in visible relief according to the slanting character of the illumination. Cracks or rills, too, appeared near their edges, and craters showed in their very midst. Patently solid, they betrayed their constitution not only by diverse topography, but by diversified tint. All manner of shades of neutral tone mottled their surface, from seeming porphyry to chalk. Belief perforce departed when the telescope thus pricked the bubble, evaporating as the water itself had done long before. So much was known before the Mars markings were named. Nevertheless, humanity, true to its instincts, promptly proceeded to commit again the same mistake, and cheerfully undeterred by the exposure of its errors in the case of the moon, repeated the christening in the case of Mars. So sure was it of its ground that what it saw was not ground, that though the particular appellatives of the several seas were constantly altered, rebaptisms, while changing the personal, kept the generic name. Dawes Ocean, for example, later became L'Oceanuten, and later still the Mare Erythraeum, but remained set down as much a sea as before. About 13 years ago, however, what had befallen the seas of the moon befell those of Mars, the loss of their character. It was first recognized through a similar exposure, but the fact was led up to and might have been realized in consequence of quite a different line of evidence, The initial thing to cast doubt upon the seas, being what they seemed to be, was the detection of change in their aspect. That the detection was not made much earlier than actually happened shows how a phenomenon may elude observation if scrutiny be not persistent, and its results from time to time not carefully compared. Schiaparelli was the one who first noticed variation in the look of the seas, and the discovery was as much due to the assiduity with which he followed the planet opposition after opposition as to the keenness with which he scanned it. The noting of change in the blue-green areas constituted, in fact, one of the first fruits of systematic study of the planet. Change in configuration, that is, alteration of area, preceded in recognition alteration of tint. Thus, the Syrtis Major showed larger to him in 1879 than it had in 1877. This was natural, difference of degree being a more delicate matter to perceive than its effect upon extent. From change of area, his perception went on to change of tone. In his own words, what he noticed was this: Memoria 6, 1888. No less certain is it that from one opposition to another, one notices in the seas very remarkable alterations of tone. Thus the regions called Mare Cimmerium, Mare Serenum, and Solis Lacus, which during the years 1877 to 1879 could be numbered among the most somber on the planet, during the succeeding oppositions became less and less black, and in 1888 were of a light gray, hardly sufficient to render them visible in the oblique opposition in which all three found themselves. On the other hand, at the very same moment, the Mare Acidalium and the Lacus Hyperboreus showed very dark. The latter indeed appeared nearly black, although seen as tilted as the Syrtis and the equatorial bays. The condition of the regions called seas is therefore not constant, so much is unquestionable. Perhaps the change produced in them has to do with the season of the planet's year. Holding as he did the then prevailing view that the blue-green regions were bodies of water, he regarded those of intermediate tint as vast marshes or swamps, and he accounted for change of hue in them as due to inundations and occasions of drying up. In consequence of losing their water, the seas, he thought, had in places become so shallow that the bottom showed through. Plausible on the surface, this theory breaks down so soon as it is subjected to quantitative criticism. For the moment we try to track the water, we detect the inadequacy of the clue. The enormous areas over which the phenomenon occurs necessitates the establishing an alibi for all the lost water that has gone. Drying up on such a scale would mean the removal of many feet of liquid over hundreds of thousands of miles in extent. To produce any such change in appearance as we witness, even on the supposition that these seas were none too deep to start with, would involve lowering the level of the water by from 5 to 20 feet throughout 2/3 of the whole surface of the southern hemisphere. This would leave a heap of waters to be accounted for, bewildering in its immensity. The myriad tons of it must be disposed of, either by drainage into other regions or by being caught up into the sky. In this emergency, it might seem at first as if the polar cap of the opposite hemisphere offered itself as a possible reservoir for the momentarily superfluous fluid. But such hoped-for outlet to the problem is at once closed by the simple fact that when the lightening of the dark regions of the southern hemisphere takes place, the opposite polar cap has already attained its maximum, in fact, has already begun to melt. It therefore absolutely refuses to lend itself to any such service. This was not known to Schiaparelli's time, the observations which have established it by recording more completely the history of the cap having since been made. Indeed, it was not known even at the time when the writer, in 1894, showed the impossibility of the transfer on other grounds, to wit, on the fact of no commensurate concomitant darkening of the surface elsewhere, and on the manifest non-complicity, if not impotency, of the Martian atmosphere in the process. The transference of the water to other dark patches in the northern hemisphere fails of sufficiency of explanation because of the limited extent of such areas on that side of the globe, while the air is quite as incapable of carrying away any such body of liquid, though the whole of it were at the saturation point, not to mention that there exists no sign of the attempt. The reader will find this reasoning set forth in Mars, published 11 years ago. He will now note, from what has been said above about the northern polar cap, that continued observations since have resulted in opening up another line of proof which has only strengthened the conclusion there reached. The coup de grace, however, to the old belief was given when the surface of the dark areas was found to be traversed by permanent lines by Pickering and Douglas. Continued observation showed these lines to be unchangeable in place. Now permanent lines cannot exist on bodies of water, and in consequence, the idea that what we looked on there were water surfaces had to be abandoned. Thus we now know that the markings on both the Moon and Mars, which have been called Maria, are not in reality seas. Yet we shall do well still to keep the old-fashioned sonorous names, Mare Erythraeum, Mare Serenum, and their fellows, because it is inconvenient to change, while, if we please, we may see in their consecrated Latin couching the fit embalming in a dead language of a conception that itself is dead. End of section 11.